think we were already shifting gears over to, your teacher hat, but for the most of the day, I think you've been sort of students, right? You've been learning and doing some of these activities throughout the day. But now we're going to switch gears and we're kind of start thinking as teachers. Okay. I know you probably don't want to think as teachers now that it's summer, but here we are. Okay. So, I think storylines are a big part. I really like storylines. I generally, personally, I'm not the best learner. I learn best when it comes to when someone is telling me a story, right? There's a lot of context, there's a lot of information. So the workshop is designed sort of more as a storyline where each day has a theme and each theme builds on another. So this is our sort of nano story that we're going through. And hopefully you'll also design your lesson plans in a similar way. So our nano story so far is day one, right? Nanoscale materials are very small and they have a lot of unique properties. And then eventually, the big idea that we're really focusing on here is that nanoscience is an important field of science that impacts advancements in modern technology. And then, I mean, to build on that, because I think our big idea maybe is not big enough, but is, you'll find a way to describe how they work, how they're made, and how they're seen, right? So you'll be able to sort of tell the whole story of nanoscience or nanotechnology. And actually, Jenny brought up a good point when we were talking is there's sort of a difference between nanoscience and nanotechnology. So nanoscience is really, and it's really subtle, and people use these both of these terms very interchangeably. But nanoscience, I would say, is more like the study and the research of the particular properties or the particular materials. And the nanotechnology is really more focused on the application, like what technologies have evolved from the nanoscience. So that is just a little thing that I wanted to mention that I remember Jenny pointing out to me, and I thought it was helpful when it came to learning more. Okay. And so this is sort of switching gears, and Jenny and Kritika, feel free to chime in wherever you want. So this is where we're kind of focusing or thinking more about how this nanoscience concept, this nanoscience information could fit into your curriculum. And I know everyone maybe has their favorite unit, their favorite section that they teach. So you kind of have an overview of what your curriculum is throughout the year, right? And so we want, or we would love if your nanoscience could fit into some sort of storyline, right? So I think I like it because I like analogies, but it's like the beginning. It's like once upon a time, there was a beautiful princess who loved science. I don't know. This is going out of control, but it's the hook, right? That's why do these students care about this story, right? And then in the middle, lots of things happen. And this is where you're connecting the dots. You're taking the hook, giving more context, filling that information in, and giving them some sort of framework to put where the nanoscience, like where is it happening? What, like, who are the main characters? What is the story you're telling, right? And then the final sort of wrap up. They lived happily ever after in their nanoscience quantum environment, or like what happens next? Does this apply to all the other stories? Goldilocks and the three bears. What happened to those bears? Are they in like Little Red Riding Hood? I don't know, but but this is where you as a teacher can sort of help provide that role of threading all that information throughout your school year. And Jenny and Kritika have a few great examples of that, which they're gonna talk about, I think, on Wednesday afternoon. Yes, okay. Oops. And so we can sort of talk about like what are the other characteristics or important parts of stories, and how does this relate to like an NGSS classroom, right? Because I believe we're all in California. Yes, we are all in California, although we may not all necessarily now be in California. But I know that NGSS is obviously a big part of your teaching and how we can make it easier for you to teach in an NGSS style, right? So feel free to chime in, or we can keep going when it comes to this. No? Okay, keep going. Yes, ma'am. Okay, so what I like are some examples. This is just for fun, but right? There's Goldilocks and the Three Bears. Home invader has cereal, breaks stuff, then falls asleep. Hansel and Gretel. Some kids eat an old lady's house. Also cannibalism. Beauty and the Beast. Stockholm syndrome girl falls for ugly guy, except he isn't. Ham-fisted construction worker, or ham-fisted construction keeps wolf at the door. Cinderella. Wardrobe malfunction prompts strange footwear mating ritual. Mattresses piled on a vegetable determine fitness to govern. So I thought these were like funny examples of stories, right? And I think it's fun. It's really there's something I think special about the fact that they're so short, and but they get the point across. Okay, so and I won't dwell too much on this, right? But a storyline is the hook. Why do we care about this? Is it something How are you going to design your lesson plan where it features all of these components, where you have your hook? How do you get them engaged? How do you get them? How do you get the students to really care about this particular part of your nanoscience story? And then, once you've gotten their attention, how do you have the connecting the dots? How do you get to understand, build upon what you've learned before versus what they're going to learn during, and then what they're going to learn after? And a big thing, right, is obviously show, don't tell, which is why this particular workshop is so heavy on activities. I don't like reading. I am not a great listener. I'm a pretty bad student overall, which is why I really personally rely on activities and manipulatives to really get to know something, right? And then finally, I really like this idea of the students become the storytellers, where I think you have really mastered something when you're able to teach it, right, or tell someone else about it. And hopefully we have this thing where the kids are so excited about a particular activity, they're telling their other classmates about it and things like that. Okay. And another interesting thing that where I was looking at was, at any point in the classroom, at any point in time, a visitor in the classroom could be able to ask the question, and a student could answer, what are you working on, and why are you working on this? I really thought that was an interesting perspective as well. Okay. Anything to add? Yeah, go ahead.
Yeah, I was just going to say one way to think about some of this in the NGSS context is the hook being the phenomenon. In other words, what are you exposing the kids to? And you'll get a lot of examples through Angela with regard to where do we see nanoscience and nanotech in the world around us. And so starting off with one of those examples as a hook, so the kids can be like, wow, that's really cool. How does that work? Or how do we know that? Or how is that designed? And then getting to some kind of activity where they can start to build a conceptual understanding of how did we come up with that, or how does that occur in nature, because a lot of the nanoscience that we're going to be looking at with Angela, it's also naturally occurring. It's not just in man-made materials that we're building. There's also a lot of biomimicry that goes into it as well, where we can look at what's happening in nature and then mimic that or copy that in our designs.
Mm. Thanks, Jenny. Yeah. Okay. And then, oops. Okay. I don't know why that's here. But and then another thing to build upon this whole storyline thing, which I also appreciated, is that facts are pieces of information, and then concepts are the things that sort of connect all the facts together, right? And this is coming from my colleagues at this Center to Support Excellence in Teaching. But quality curriculum materials are organized around key concepts, and essential facts are connected to those concepts to create a coherent storyline, which I thought was really nice way to think about how you organize the information. How are you telling that information to your students? Okay. All right. So, I lost my mouse. Where did it go? Oh, here we go. Oh no. Okay. Okay. So here we have. Where's my mouse? Okay. Sorry. I'm gonna turn off my video. I think my memory is just maxed out. Okay, so let's go back. Okay. So I think by the end of today, this is sort of your reflection homework where you want to sort of, and these are just leading questions, okay? So you are welcome to use these or use your own when it comes to building your curriculum. But, what is nano, right? Today was it's really sort of, it's syllabus day, right? It's kind of an overview of what's going on. But I think you should sort of start thinking about where would nanoscience make sense in your classroom? Are there certain sections of your could be sort of supported where Jenny mentioned the phenomenon, all the sort of interesting things that are going on when it comes to nanoscience? Could that be the hook that is getting you interested or getting your students interested? And I think another thing is, what do you care about, right? This, you're the teacher and this is your workshop, so you can shape it in any way you want. Are there any particular nanoscience materials that you want to focus on, or any sort of nanoscience topics that we sort of touched upon today, that you would want to look more deeply into to design your lesson plan? And then I think another thing is when, and obviously you know your students best, and you know yourself best, right? So what are some misconceptions that you might have had, and what misconceptions your students might have had when it comes to nanoscience? And then another thing I wanted to mention was when it comes to developing the lesson plan. So by the end, the goal is for you to submit some type of lesson plan. It does not have to be a fully fledged and fleshed out lesson plan, but it does need to be at least some groundwork needs to be made when it comes to creating something that you will ideally use in the fall to achieve your implementation stipend, as well as just to implement nanoscience into the classroom, right? Um, so this is a big part, but you're also welcome to work with a partner on your lesson plans. You don't have to do it alone. And I know that there are some people who are already in the same school. So feel free to work together if you want. That's totally fine. Okay. All right. Okay. And so a big part, and thanks to Jenny for these slides, but I think I want to make a point of talking about how maybe this is a little bit of propaganda, but I want to make it clear that nanoscience is a really important part of NGSS, or can be a really important part of NGSS. So where, oops, okay, so, okay. So, right, there are big sections of NGSS where we have the science and engineering practices, how scientists and engineers investigate, build models, and design new materials and devices. We already did a lot of that today, right? The self assembly, that's how some scientists manipulate different types of matter in order to create new nanomaterials to design their experiments, right? And nanotechnology, obviously, yeah, like I said, is really good part. Stanford, I am your new channel to access Stanford, right? So if you want a guest speaker, if you want people to talk about their research, I am happy to connect you with any type of student, or teacher or professor. Bruce this morning was a really great example of that. Bruce is very knowledgeable. He has been in the field for a very long time, is a distinguished professor. So we have that capability. So please leverage us. Please use us. Um, and then also investigating and building nano. There are all these different techniques. We haven't touched upon them today, but we will talk about them tomorrow and the day after. And there's all these different tools, which right now mean nothing to you, but they will mean something to you later. So you can always revisit the slide. But all this stuff that is surrounding nanotechnology really fits into this science and engineering practice because we do it as scientists, engineers. This is our practice to create nanoscience and nanotechnology. Okay. Um, and this is an example of this. I'm not about it all later. Okay. So then another thing is these cross-cutting concepts. Can you guys hear me okay? You can't, I think the video is messed up, but you can hear me, correct? Okay. All right. So then again, with other parts of NGSS, right, are cross-cutting concepts. So I already talked about it earlier today, but what I love about nanoscience is the fact that it's so interdisciplinary, right? And so they're able to touch upon a lot of different types of content, or just like dip your toe into different types of content when you talk about nanoscience, right? Things that are nanomaterials can be injected as nanomedicines. They can be assembled as nanostructures that are inside of your devices, especially when it comes to computer science. So many different things. A few examples of the cross-cutting concepts on the left side really fit into some of the nanoscience concepts that are here. So self-assembly, that's sort of where students are trying to recognize different types of patterns, right, throughout the design of their magnets or design of their floating magnets, right? What can you see? What are you observing? What are the repeating patterns? What are the attractive repulses doing? What are the uh, uh, attractive forces doing? What are the repulsive forces doing? We also have examples of things that I'll talk about a little more later, but the cause and effect, right? What happens when you we can talk about it in the sense of self-assembly, but when you have these magnets separated, what happens when you shake it up? What are the causes and effects of that? Nanoscale, the card sorting activity is a direct correlation to scale, proportion, and quantity. We also have all different things with systems, and we will talk about this a little later, but there are different types of concepts that are related to that. Energy and matter, again, we touched upon it a little bit with the light and wave interactions. And then all other things like structure and function, we talked about that with the carbon activity, or a carbon demonstration with all the different allotropes. And then stability and change, which is another thing that we will focus on a little later. But what I want to reinforce is that nanoscience is really something that is really important to so many parts of our self. We are made up of many different atoms and molecules, and we are self-assembled. And we are sort of this dynamic system of us being constantly self-assembled and sort of disassembled. But then the materials that we touch and make and use, our computers, there's billions of transistors inside of our computers that were made through nanoscience and through nanotechnology. Some of the lotions and the sunscreen and things like that we also use that are really important when it comes to nanoscience or nanotechnology. Okay? Any questions so far? Any comments? Okay. Your computer's so unhappy with me. I'm just gonna. All right. Okay. And then the next generation science standards. So interdisciplinary core ideas. So this is where we have life science, earth science, physical science. These are just a few examples, and I won't go into it too much detail for the sake of time. But again, nanoscience is the study of matter and energy at the smallest level, underlying all sort of disciplinary core ideas. There is all sorts of things that are happening. Earth science, how do we assemble crystals? How are fossils made? Life science, how are we assembled? What are the ecosystems? How does a sperm and an egg connect? Physical science, right? Electromagnetic spectrum, wavelength of light is within nanometers, things like that. And yeah, okay. All right, let me keep going. We're almost there. Okay. So we are going to sort of talk about the 5 E's. Is everyone quite familiar with the 5 E's? Let me show the video panel. Yes, no, maybe? Okay, so I won't go through this too quick, or I won't spend too much time on it, but I know that my colleagues through CSET, and I think Jenny and Karithka are also quite familiar, but I think this is a nice way to teach science because it's such a popular model, but also it's just a nice way to think about how to learn. Again, it's still this sort of hook storyline situation on how to build your lesson, right? So you're engaging, that's your hook. Exploring and explaining and elaborating, I think really fill in the building your storyline and building the cross-cutting concepts and things like that. And then finally you have your evaluation where you're trying to figure out whether or not whatever you threw at them sunk in, right? And so I think that really helps when it comes to building out your lesson plan. But again, I won't focus on it too much. Okay. But what I would like you all to do is sort of think about the 5 E's and today's work, where you could think through on whether or not some of these activities would be good as an engagement or an exploration and explanation, how you would evaluate something and or how you would elaborate something. Right, so we could spend maybe till 3 o'clock sort of thinking through some of that or some of the content we talked about. Does that make sense to everybody? Does that work? Okay. So and we can discuss this as well. I'm going to stop sharing so you can see me. And yeah, okay. I missed so many messagings. Okay, this is great. Okay. All right, so what we're gonna do is maybe everybody spend a few minutes just thinking through the 5 E's and how either the magnetic self-assembly activities, the floating one, or the shaking one would make sense, or even the card sorting activity, like how they would fit into the 5 E's, and in particular, maybe your classroom. Okay. So feel free to write it down or just talk about it, but it would be great. Okay, does anyone want to share their thoughts on the 5 E's and how this may fit into their classroom, or just sort of discuss some of the activities? Don't be shy.
I guess two things that kind of stood out to me. I think doing like physical and chemical reactions, something I did in 7th grade this year, and I think that there's something definitely to this, especially about thinking about reactions and increasing the volume. Basically, just make it smaller, crush it up, and how that affects the reaction, and having students doing some sort of design process with that. And then because I'll be teaching astronomy elective next year too. So I'm developing curriculum for that right now, and this has given me a lot of cool ideas, especially thinking about scale and thinking about self-assembly in space as well.
Yes.
That's something that I was interested in as well. I know nanotechnology in space, and there's a lot of really cool stuff that potentially to think about and add. So.
Yeah, actually, that's a really good point. So, the creation of galaxies and universes, I mean, it starts at the atomic scale and then it really explodes out from there. So, yeah, there's something poetic, right? Something really big becomes then really small. So,
yeah, and just getting students to think about, how we came to be, and thinking about like elements and atoms of where their like steady state are, and how do you get to store, and like designing and how things work and everything coming together from small to big is really cool to think about. Because space, we tend to, I think, just automatically just go to the big scale, but the small scale is the foundation of everything. So yeah, those are just my thoughts.
Yeah, thank you, Dustin. That's great. Anybody else? I know some people have sort of dropped off. What about like Julia or Portia? Did you want to share any thoughts?
I really like the card sort as an engagement for the kids, because that's some of the stuff they recognize, and the big scale stuff. And then even some of the smaller scale stuff, they may have heard about it and stuff, and they can try to problem solve together as a team and try to figure out where it goes. But I think that's a really good introduction to give reference to size. So I really like that.
Yeah, thank you. Okay. Oh, and then I see Leo said, oh, it echoed a talk. Oh, building a dinosaur from a chicken. Okay, awesome. So, and yeah, if there are any resources, sometimes the chat doesn't save, but if you want to email them to me, I'll try to click on this now. But if you want to email any additional activities or resources, feel free to email them to me. I can add them, because we'll have eventually a running list of all the resources and slides that we went through today, and obviously throughout the work week. Okay, anybody else to add? Anything else to add? Otherwise we can keep moving along. I'm happy to hear other opinions. We really love that, because I feel like I've been talking a lot today and I don't really like doing that. Okay.
I was just going to comment, Jack Horner and a lot of other protein scientists have been talking about like the technology that the Japanese have developed with like folding paper.
Yeah,
origami. And it just does the origami structure. Exactly.
Yeah.
So you know what I'm talking about.
Yeah, it's really cool. If anyone hasn't heard of what Leo's talking about, they actually fold this paper like through methods of origami, but they fold it, and then it's a particular type of paper that once exposed to water, it starts swelling up because of capillary action, and it just like unfolds very cool and interestingly. So I think that is a really nice addition. Yeah, thank you. Okay. Any other questions or comments?
Just building on that is like satellites and having like solar panels that are all tightly compact, like the James Webb Space Telescope, and having to design it so that it can more naturally just open up instead of having to have all these motors do everything. Looking towards origami for a satellite design is cool too.
So actually, in a past work life, I worked with the Boeing engineers, and they were talking about, they were satellite engineers, and they thought about what's called this condition, which is called dynamic constraints, which is how do you think about a giant solar panel being folded up to fit into the nose of the rocket to get sent out to space, but then how would you deploy the solar panel in space, right? There's no gravity, it's very hard to get a force going. So they actually use very controlled explosives to eject the wing out. So I thought that was really cool. But yeah, and we actually designed some like activity around deploying different types of hinges and wings and things like that. So yeah. Okay. Anything else? Anyone else want to add? Maybe Amy or Amrit? Okay. All right. So I'm gonna. Oh, Amy, did you want to say something?
That I'll add for 7th grade science. This past year, I used the Stanford scale curriculum, and there's one of the units is all centered around water. So when we talk about changing state, and there was a part of a lab where they observed just same volume of water versus ice, and talking about why ice is actually less dense. I could see like the engage being observing ice cubes and water, and then as some of the explored using the magnet pieces to talk about the crystal lattice framework of the water molecules. I think that could fit in really well.
Yeah, that's really good. And actually there's a secondary activity, and maybe I can share it too, but you combine water and isopropyl alcohol, and you combine you measure out 2 volumes, like isopropyl alcohol and water, but then you mix them together and they don't actually add up to the same volume. And so it really messes with your brain and messes with the student's brain on that. I can find it and send it to you all, but I'll make a note of that. All right, awesome. Anything else? Anyone else? Otherwise we can keep moving. Okay, so today, let me share my screen again. Okay, so this is, and I will share this with you on the I think I probably already have showed or shared with you on the Google Classroom, but this is just a general lesson planning guide. This is a way to have a set of guiding questions for you to answer to help you create your lesson plan. They are by no means the final thing, and if you think there are better questions to ask, please feel free to modify them. But the idea is for you to make a copy of this, and this can sort of serve as your little like journal when it comes to getting information down into your little brain cells. But what I wanted to focus on was sort of, day one, this is what you would want to answer, right? Which we sort of already reviewed. But ideally, this is part of your homework where you're thinking through all the different sections of each day and sort of building out kind of like a jigsaw puzzle, really, your lesson plan. Because we want to set you up for success. We want to get you, your whole stipend. Part of it is making sure you participate during the workshop and get a lot of information. But the other half is, when you go back to your classroom, how are you going to implement? And we want you to implement. That's really important to us. We want to support you in any shape or form that we can. All right, so, and maybe they're not in the right order that you want, so feel free to take a look at this and review it a little bit more closely. And a big thing, I think another thing to really consider is how do we make this work for everyone? And then how do we make this work remotely for everyone, right? I think we have all different types of learners from all different types of backgrounds. We've already sort of touched upon the fact that, some of the materials that I've given you, you may not all have easy access to. So trying to help me brainstorm ways to really better serve you is also really helpful, and things like that. So I would love it if you guys could spend some time today as maybe part of your homework, but to really think through some of this. This could be the final lesson plan if you want to submit it like this. We will have, by the end of Thursday, everyone will present a short overview of their lesson. Okay, so by Thursday afternoon, sorry. Okay, and then going back, I won't spend too much time on it right now, but we will take a quick 5-minute break to actually work on this, okay? So please, you should be able to view the lesson plan, and I'll actually put it in the chat box. Hopefully you can have access. If not, I will, you should be able to access it in your Google Classroom. Sorry, I can't remember that word for some reason. But you should be able to access it, and then we'll spend 5 minutes right now to write something down. You can make a copy, and so you can have your own copy to write whatever you want down on there, okay? And then another few questions that you should also sort of consider, right, is where is nanoscience fitting into your class? And we already talked about it a little bit, but take a moment to actually write it down. I know we talked about it. So I would take some time to write it down, think it through, and just think through how we could make this work. I don't know. And I think another thing is to talk about maybe concerns you have when it comes to making it work maybe remotely and things like that. Okay, so we'll spend 5 or 10 minutes. We'll play it by ear. We'll see who's ready to talk about it or not. Okay. And if you are having trouble accessing the document, please let me know and I can help you get there.
Can I ask just for clarification on the Google Classroom?
Yes.
When you've issued that file to us, it has our name as a prefix to it. Is that our own copy or do we have to make another
Yes,
copy?
that means you have your own copy. Yes.
So we can edit that direct document, right?
Exactly, yes.
Okay, perfect. Okay. I thought we had to
Yeah.
make another copy of it.
Angela, where's the document with like the questions that you showed?
It should be in the Google Classroom stream for day one.
Day one, okay,
Yeah. And for the day one materials.
got it.
Angela, I can't find it either.
Oh no. Okay. Let me
Check. I'm under day one materials, and then it's
yeah,
like,
it's called final lesson plan, and then under
okay.
that it should say lesson planning reflective guide. Yeah, let me share my screen so you can see. So it's this here. So then this is the guide that I was talking about that you should be able to click through, and it'll be your own thing. And then later we'll come back to this because then you'll drop your lesson plan into this folder. And then this, just for reference, if you want a template, is the NGSS 5E planning template if you want to use that, but you're welcome to use whatever lesson plan template you want. So that's why I kind of pivoted over to general guiding questions than a structured template.
I only see the template and the lesson plan Google Drive link. I don't see the third document.
June, I know, I think on the right-hand side, there's an option there. Click, I think you see your turn it in or submit or something like that. Click over there.
Oh yeah, that's where it's at for mine. Thank you.
Oh, yep, found it.
Okay, thank you. Sorry.
No problem.
Okay, so we'll give it a few more minutes and then we can share out. You guys ready to discuss, or does anyone want to share what they wrote down or had any thoughts on?
So like what we wrote in our lesson planning reflective guide?
Yeah.
So I basically just talked about how we just started using a new curriculum this year. So I'm kind of adjusting to how they've arranged things. And one of the very first lessons they go over is atoms and elements, and they introduce the atomic scale at that point. And scientific notation, which the kids typically don't get until 8th grade for math. So I end up spending a little too long on that. And I think that the very first activity we did would be incredibly helpful with that, at least to give them perspective, because I was so underprepared with that.
Mm-hmm.
And then we also talk about how if you keep cutting something up, it doesn't retain the same properties. And so I liked your examples with the different colors. I thought that was really cool. And then misconceptions. I think my biggest epiphany is like the Alka-Seltzer thing. That breaking it up like that, it went so much faster. And I see how it's related to surface area and functionality. So I think that would be a misconception, is assuming that like the whole tablet would go faster or something. Another one would be assuming that in relation to cutting something up a bunch of times, is that nothing about it will change. It'll retain the same physical properties or whatever it is. Because I did have kids think that at first this year. So
that's great. Thank you. Yeah. Yes, did you have something to share?
Yeah, I can share. Yeah, I like this magnetic arrangement. It's the, we've been working on chapter 2 is about our chemical reactions. And we did use some of that kind of activities, but it gave me more ideas because I can show the kids how we can arrange these atoms and creating some synthetic material, like for example, plastic. We have so different kind of plastic, and we can look at these arrangement of these atoms to come up with new kind of medicines, or if you find chemicals in nature, like in rainforest, and we analyze it, and then we see how those atoms are arranged and give us new kind of chemicals or medicine. So that's a good way to explain to the kids. So I like this, and I'm going to use that more in the class because I guess my visual learners can benefit from that.
Yeah, that's great. Thank you for sharing. Yeah. Okay. Anybody else? Usha, did you want to share something?
I could share.
Sure.
I'm going to be teaching the STEAM elective next year. So actually right now we're in the process of developing the curriculum for that course. So I was thinking this nanoscience curriculum would be a good idea to start because everybody would have the same level playground.
Yeah.
Some people know everything, some don't know. In this case, I'm hoping that everybody won't know a whole lot. So we all have a common step to start off at. And one misconception I was thinking was like when the kids hear about the word nanoscience, they've heard nanometer. So I'm thinking that once I give them the word, they'll think everything measured in terms of nanometer is a nanoscience.
Yeah.
That's what I'm thinking. That's all I have to say.
I always think about the iPod Nano, maybe it's because I'm old or something, but yeah, like they talk about like, oh, maybe people are just only think about the iPod Nano and not think about it's like a marketing ploy. Okay, but we're gonna start wrapping up. I know, asking you guys to be online for 4 hours is a lot. So we are going to start wrapping up a little. So I sent, and this is just got posted in the Google Classroom, but you'll see on here the gots and needs. So please fill that out. It's your kind of like little exit ticket. And basically every day we're gonna go through this exercise where you tell me one thing that you got and then one thing that you need. Okay. We'll see how it goes because usually it's like a post-it note that you stick on your way out the door, but today obviously it's not really like that at all. But this is sort of our way of sort of getting a check-in and just a temperature check on, how we're doing, what you need, how can we better serve you and take care of what's going on in the workshop. And then so while you guys are doing that, I have a tiny URL too. Let me share can you see my screen? Yeah, wait, can you? Yes, you can see my screen. This one, right? Okay. So if you can't access it, there's also a tiny URL version of it online. Oh no, okay. Okay, you got it? All right. And so now we're gonna have the challenging thing of assigning some homework. I know homework always has a bad connotation, but hopefully it will be a fun connotation. So you're gonna do this thing called nanos. Did you guys see that? There were little like magazines. Let me show you one of them. Okay. So everyone kind of got a variety of them, mostly because I wasn't able to give everyone an individual version, like an individual packet, so I had to mix them up. So what we're gonna do is really quickly, everyone is gonna try to pick one, and then we're gonna try to have a variety of groups, all right? So I'm gonna do this. I'm gonna assign real quick groups. And you're gonna and I'm gonna put you into quick breakout rooms. And what you're gonna do is basically all of you need to have individual nanoses, different issues, okay? So I'm gonna assign you into breakout rooms, and then what you'll do is make, how do I do breakout rooms? My breakout rooms are gone. Oh, you know what? I think I'm no longer a host. Okay.
I think I'm host now. I'll make you host.
Fine. You know what we're gonna do? Okay, Samantha. Okay, we're gonna do Samantha, Dustin, and Julia. Okay, you're gonna be a group, and then do you guys mind saying or typing in which NaNews you're gonna read, and hopefully work it out amongst yourselves that which ones you're gonna read, and then we're gonna do June, Fiaz, and Amy. Okay, and just feel free to put it in the chat which NaNews you're going to read. You should have at least 3 issues so you can work out which ones you're going to read. And we'll do Usha, Amrit, and Yanette. Okay, and then we'll do Leo and okay, and then Vicky. Okay, well, yeah, we'll do Leo and Vicky, and then Anna and Portia. Is that everybody? 1, 2, 3. Am I missing somebody?
I didn't get a room.
Oh, Joanne, I'm so sorry. Okay. All right, we'll do Anna, Portia, and Joanne. Okay. All right, so Julia is doing issue 11. Okay, Samantha, sorry. Samantha, you are Samantha, Dustin, and Julia. Okay, Samsung Galaxy X7 is Yanette. Yanette is issue 8. Leo and Vicky, okay, Leo, Vicky, 9. Sorry, this is a little crazy. Okay, Portia's gonna read issue 7. Okay, Samantha is doing 12. Amrit is doing 13. Okay, I'm writing it down so we can double check if anyone is copying, or I can, and I'll message you all the groups on the stream in case anyone forgets. Okay, Joanne is doing 8. Perfect. You guys are all different. Good. All right. Anything else? Okay, while you guys are doing that, I also wanted to give you a quick update on what we're doing tomorrow. Okay, or in general. So for tomorrow, we're doing a thing called Jigsaw. So this is where we are going to assign into groups. Right now, we just assign them. And then if anyone hasn't put in their issue, please put it in the chat so I can write it down. And then what we'll do is you'll get into breakout rooms in the beginning of tomorrow, and you'll do a discussion diamond, which I really, really like. I think it's really fun. We're gonna test it out because we've never done it remotely. It's always more fun to do it in person and markers, but we'll see how it goes. And then obviously part of your homework is sort of thinking about and developing out your lesson plans. And again, if you have questions on that, I'm happy to stay longer and discuss that in further detail with you. I know day 1 is a little hard too, to actually wrap your brain around everything. So just, have it churning in the background, but maybe you won't really start working on it until today or tomorrow or the day after. And then finally, the biggest ask I think for you guys is to actually make some stuff either overnight or early tomorrow morning, because we do have a few activities. So one big thing is the sun print lithography. You just need to actually prep the materials and just gathering them, but you'll need to have water accessible. The suite self-assembly, the suite self-assembly is the biggest ask, I would say, is where you are actually prepping certain materials. So there's the alginate solution and the calcium chloride solution, okay? So you can decrease the amount. So it says half a teaspoon with 1 cup of water. You can decrease that into a 1/4 teaspoon and half a cup of water, or even less. But I recommend you to make it in advance because it becomes this kind of gel stuff And if you don't give it enough time, it won't actually dissolve properly. Okay, so what I might even do if you're feeling real tired, which is fine, is just take the water and just dump the teaspoon in and just let water do the work, and then just double check it in the morning. Okay, the calcium chloride shouldn't be a problem. It dissolves very readily. Okay, and if you want to have fun with it, you can actually add like flavoring, or you can add colors if you want to do that. I've done it with like Powerade and like juice. It can be kind of fun. And then the thin films, you should have almost everything except for paper towels and water. Okay, so the biggest thing is this one right here. All right. Okay. All right, is there any other updates? Okay, Dustin is doing 15 or 6:15. Leo is doing 16. Usha, did you say which one you were doing?
9.
Oh, 9, I see. Okay. Okay, June. I think we're just missing, June, Fiaz, and Amy. Did you guys have the ones that you're gonna do?
Do we have to pick one that hasn't chosen, or is just
No, it's just amongst your group. So the 3 of you did not. Yeah, just pick one and pick one you want to read really quickly. Yeah.
All 3 of us will be reading the same one?
No, you all reading different ones.
Okay.
Okay.
I can do 7.
Okay, Amy, 7, Fiaz is, okay, June is 15, perfect. And then, sorry, Amy, which one? Or Fiaz, which one? Fiaz.
Hi, Angela. Okay, I'm sorry. The number they're giving, my group is giving you, what those numbers are for?
The other ones were the issue numbers. So June is doing 15, Amy is doing 7, and then which one are you doing?
I mean, where's the number? I'm looking.
Oh, the number is in the top right corner, very tiny.
Oh, okay. So my issue is 4.
Okay, perfect. Awesome. All right. So everyone, we're going to meet back here tomorrow morning. I will be on maybe 5 or 10 minutes early if you want to come chat, hang out, drink some coffee with me. Other than that, please make sure to finish your gots and needs and submit that. Work on your lesson plans. If you haven't done your pre-survey, please do your pre-survey. It really helps me make sure we can keep doing this and helping other teachers, supporting other teachers. And yeah, that's about it. Okay. All right. So I'll see you all tomorrow. Have a lovely day. Thank you for being here.
Thank you.
Okay. Bye.
Bye.